So, guys, thank you very much for taking the time to hear our presentation. Also, thank you very much to the organization of the event, René, Paul, for having us. We rejoice the opportunity to talk to you about this scoring model that we've set up, and we're going to try to contextualize that a little bit. So, we split the presentation in two parts. So, the first part, which I'm going to take care of, which is kind of contextualize it in terms of search management and what was how the world looked like before BigQuery and big data, because some of the practices are outdated, but some of the problems still remain. And basically then Georg will overtake and explain the model itself and contextualize it, how we plan to use it to help us and guide us in the transition from our third-party search solution that we use today to the open source search solution that we plan to use in the future. So let's just jump right into it. So basically, contextualize it a little bit in terms of search management. Well, from all tools that we have in our shop, the search is definitely the most important one. I guess you all have very similar numbers to that, but I mean, the search is only used in our shops at around 30% of the sessions, and it's still responsible for over 50% of the overall revenue from our shop. So a session in which the customer is searching has a very big conversion potential. And these numbers are kind of average for our whole group, and they have improved in the last year. So we definitely see a lot of potential in there. And yeah, we want to stay relevant when customers are searching for something in our shop. Unfortunately, the resolution doesn't help it. But well, it goes from very simple queries like iPhone 6 until very sophisticated stuff like Philips Fernseher mit Ambilight and Dolby Atmos. So this is kind of a custom plugin that we've developed in the past because we realized that this was a real happening use case. People were like using the voice, the microphone to give us this kind of queries. And it works fine for us. It doesn't work so well for other people. And I don't mean to say I don't mean to say that our search is by any means better or worse than anybody else. It's just we invest a lot of effort and sweat into, staying relevant for the customer. But, well, and here René and some other colleagues spoiled a little bit of the fun. But I mean, keyword matching and relevance model is just a part of the deal. So there is really a lot more to consider in e-commerce, consumer electronics search. So imagine people are searching for Samsung Galaxy S5, which of course don't have. What do? Do I show newer Samsung models? Do I show other kind of smartphones that are more or less in the same price class? Do I show accessories for S5s? Same problem with televisions for 55 inches. Well, we definitely have a few true positives for that query, but is any of them available at the nearest MediaMarkt or Saturn market here in Berlin? Or even, for example, the margin of some specific kind of products. People are searching for HP 301 or the HP 301. Well, our keyword matching will probably find that kind of product, which is a single cartridge for that printer. But what if we could have a better margin by selling the XL variant, or even a kit with many different colors at a time? So as René said before, there's a whole world of seller perspective here, which has to be also considered. And again, as the colleagues from Otto also said, we aim for that sweet spot between customer relevance, which definitely is a goal, and also all this kind of business-related stuff that we want to realize via search. Some examples of that, and maybe I would like to say something at this moment which wasn't said before. For us, it's a fact in consumer electronics that the business is changing, and it's less and less about getting the customer through the checkout and pushing that product to him, and it's more and more about things like services, attachment rate, getting an accessory to be also sold or a service, and the whole process of selling stuff, it's becoming more and more like selling an experience, also like some kind of convenience service, where shipping a product to your home is just one part of the whole experience. And we will see more and more of that coming in the next few years. So that also plays a very big part here. Well, And now, again, talking about the world before BigQuery, big data analysis and models, well, we still needed back then to have some kind of control. Do we hit that spot? Are we relevant, and are we realizing our business goals at the same moment being relevant? So one of the things we used back then was the classical like NDCG calculation. I think you pretty much know this. So the NDCG is basically the comparison of a list with the perfect sorted variation of that same list. And well, that enjoys a lot of respect among the community, and also managers like it a lot because of its mathematical framework. So you do NDCG, so people are like, wow, you do NDCG, that's great. But it still left us with two problems. Problem number one, well, a perfect sorted list of average products still has an NDCG of 100% in that model. So, well, and the second problem, which is even worse for us, people are saying like washing machine. So you have like 20 products and they are all perfectly matches, like threes. How do you identify within the true posits which is the most relevant washing machines? Because if you're not showing stuff which is really, really relevant in the first 5 to 10 positions, you're done. So to complement that, we used a kind of a second model, which was the wisdom of the crowd precision model, in which we got, you know, testers, like people in different teams, different unities of our company. Usually we took the ones that most criticized the job of the search team. And we asked them, well, listen, we're going to send you some queries, you're going to test it. And the criteria was like very objective, the matching and the ranking. So did you find the correct products? Were they sorted in a way which makes sense for you as a customer? And well, there are 6 different scenarios which could come back of that, which the percentages in which how often does a scenario come up. And you see, well, at least in our top 4,000 query area, which is more or less our short area, I'll come to that, we are pretty good. And that model, even though it doesn't have the whole respect of the NDCG, it helped us a little bit to get into the soft facts aspect of things. Like, because of the way this test was formulated, the testers were motivated to give for feedback about other stuff, like the general overall impression of are the facets working? Is some kind of teasering happening that is bothering me somehow? So we get into some other aspects. And because of that, we also have the possibility to kind of dig deeper into assortment problems, problems in the product data, and of course, some kind of search optimization that it's needed. And yeah, that model also helped a lot in kind of to get this short head query area under control. So even before BigQuery, big data, we pretty much knew what was happening here. But we had a problem. And the problem was, at some point in time, you come with that kind of process, which is like mainly manual or semi-automatic, to that point where you say, well, now I give up. Which is, I mean, our scenario is a little bit more merciful than auto. So in the first 4,000 to 5,000 queries, I already have about 65% of my revenue covered. But if I want to go for the next like 7%, I would have to put double as much effort into it. And we are already mobilizing back then around 20 people in different teams to get that done. So basically that's where the time where you start to rely on indirect search optimization. That means I hope I've optimized my data models here enough and my ranking models enough that I'm showing relevant products also beyond that. And well, what we also did with some kind of segmental incursions where we identified that people were searching for like always with a specific price range in different forms, and then we could optimize that and products with features, etc. But all of that had a very high, involved a very high manual effort from our side. So that was one of the motivations to go, you know, for that model approach. Well, the second problem that also with the wisdom of the crowd practice unresolved, that still is unresolved, is the topic, how do I sort the true positives within my list? So basically at that moment in time we had one very big support from our search engine, which is FactFinder, because FactFinder has this automatic search optimization going. in which basically the clicks, carts, and purchases on products after a search were kind of tracked and scored. So that Fact Finder was in parallel to all the things we were doing. It was also optimizing or re-ranking products within a list. And that was also a thing that we said, well, that's cool, but that's working like on a global level. What if we could do that on a query level? And that's when we started to build up our own model, which first works on a query level, and second takes also the price range into account. So in a nutshell so far, we aim for customer relevance, but there's a lot more to consider. All the process that we had in the past, they gave a pretty good overview about the short-head query area, but we still didn't know what was happening in the long tail, where 35% of our profit is coming from. And we are doing all of that with significant manual effort. So for us, automatization, having this kind of model running was the perspective to solve two problems. One, understanding and managing the long tail query area. And second, trying to get an understanding within the true positives, which is the best match for a query.
Okay, can you hear me? Okay. So when we first start to building something that helped us, we had the problem that we didn't know if our ranking is perfect, if the products all appear that we want to have, and if they are sorted correctly. So we had to build something like a second view. And the second view should be able to build the connection between the search query and the products. And we wanted to assess something like an inherent value of each product, something that is steady, even though if we have marketing campaigns, because brand reputation, because is the product useful at all? Does it have a lot of competition of similar products? This is very steady, and if we have price reductions by maybe 5 or 10%, then the revenue goes up by 100 or 1,000% sometimes, so we have to take care of these effects. And the last point is, we needed something that can start from any point and develop to something that is better. Even though if we had a bad start, a bad search solution or a good search solution, we have a lot of sales lines, 12, I think, and they have different search solutions, and we wanted to have an overview if they perform good or bad. So how does the model work? Let's assume we have an online shop with 10 different products, A, B, C to L, and they can be found with one search query XY. So let's look what our users are doing. The first user might be clicking product B and F, the second, or not clicking but viewing, the second D and L, the third E and F, and so forth. So we had, at the end of the day, we had an aggregation over the relevant products, and we had a ranking. So the most important product would be F, the next one D, and so on. But just to look at the detail views, product detail views, and not clicks, because clicks are too close connected to the current search solution, and we wanted to have something that works a little bit more general. We also integrated add to carts and purchases, and because purchases deliver a more valuable information, we introduced weights for all of the three, and then we had a ranking formula for the score for each product within each search query. And the weights are currently calculated like this. We compare the detail views in the relation to the purchases, and the add to carts in relation to the purchases, and the purchases to the purchases. So we have the weights, but how do we get this model very general to work? If we look at user sessions, one user session might look like this. User entered the website and searched for Apple iPhone. Then he viewed one Apple iPhone, then he put it to cart, then he searched for TV, and then he saw two televisions, Samsung TV and Sony TV. now what's interesting about this model is how we attribute the value. And we do it for the first view, a little bit chaotic, and deliver a very noisy result, but it's just for the one session. We have several effects, some beneficial effects and some disadvantages, but let's look deeper into the model before we see the results. Here we have just one session. How many sessions do we need? It's similar to an A/B test. You need a lot of sessions to be significant. So the first type of error is to not wait long enough. And the second type of error is to wait too long. So something changes in between and your data gets outdated. And the ideal time frame is somewhere in between these both positions. And the minimum error depends on the data that you have. If you have a lot of data, or you have queries that generate a lot of data every day, so the one query could be significant after 1 or 2 days and another after maybe 30 days. But this is not the only point. It's also important to have campaigns, marketing or advertising campaigns in mind. Because advertising campaigns, like this one, we have here, maybe we have a situation when a user comes on our web page and has a short list in mind. Should I buy smartphone A or smartphone B? It could be an Apple iPhone XR or an Apple iPhone 8. Which is the better one? Here we have the development of the daily score. For each product, we see the peak for both products. So we had some kind of pricing campaign or whatever. But we see a difference at the end where the Apple iPhone 8 on the right side increases over 6 days a lot. So is the Apple iPhone 8 more important, more relevant? The thing is, currently the model doesn't understand if the price will be reduced in the long term, or just for several days. So it has to take into account both situations. So it has to react, not so much to react on campaigns, but also react a little bit. So if we compare to get back to the situation of the user, so the second date to compare these both scores, the iPhone XR is maybe 30% above the iPhone 8. Here, the iPhone XR is also maybe 30% above, but at the end it gets interesting. At the end, we use this score to define which is more important. And because of the last 6 days, the iPhone 8 had the edge and is a little bit higher than the iPhone XR. So that would be the ranking and the recommendation from our side. This is the formula we use here, a rolling median and a logarithm. Let's look at the results. Okay. This is one of the ranking for the search query Waschmaschine, the washing machine. We see there are some products more relevant in the green, from the green columns, and some are not. And one of the purposes for us was to compare it to the real search results, so to the real results from the web page. And we see here we have the real results, and if I highlight the washing machine inside of the product name, we see that all products have the washing machine inside of it, so which is pretty good. So all products would have an NDCG of 1, so a perfect solution. But let's focus on these 2 columns. We have here in this both columns, we have the comparison between both rankings. We see there are differences. We see on the product on the first position on the right, in the right table, is on position 1, but from the collaborative filtering model, it should be on position 11. So here the current model acts differently, and we should punish a little bit. So on the NDCG, which is calculated on the right table and uses the collaborative filter table as an ideal NDCG. And so we get the information automatical, how good it performs for each search query within, I think 1,000 products, 1,000 search queries from MediaMarkt Germany. Let's look at the next result list. Here we have the search query iPhone X. It's maybe a little bit more intuitive to interpret the results. And again, we have on the right side the result from the web page, on the left side the collaborative filter model. What we see here is both models find all iPhone X that we had at those time on the top. The difference is that on the left side in the collaborative filter model, we had the both cheaper models on position 1 and 2, and on the website we had those time the both cheaper model on the position 3 and 4. So this is the first difference. The second difference is that the current search result had the common element was the string iPhone X. So it displayed iPhone X and covers for the iPhone X, while the collaborative filter model displayed iPhone X or similar priced smartphones like the iPhone XS, XR, iPhone 8, even the Samsung Galaxy S10 on position 13. So it also acts a little bit like a recommendation. NDCG for this was 0.72. Let's look at the last result. Here we have two tables from two different sales lines, MediaMarkt Germany and MediaMarkt Austria. And here it's interesting that MediaMarkt Germany has a lot more traffic than Austria. And so it's interesting how the data will be, how the result quality will be if you have a lot less data. So for MediaMarkt Austria, we had 30 unique searches over the last days, and for MediaMarkt Germany, we have 500. So the search term is Samsung Galaxy S7. Let's highlight it in both tables. For MediaMarkt Germany, for MediaMarkt Austria, the only Samsung Galaxy S7 is found on position 1. So this is only the collaborative filter model now here, no comparison to the real world. And for MediaMarkt Germany, we have 5 different Samsung Galaxy S7 with different colors. The black one on the top, and then the other ones. So why do we have gaps here? Why aren't all Samsung Galaxy S7 on the top positions? Is it a bad result? I don't know. If we look at positions in between, we see that there are all products with classical colors, like black, gray, silver. So the color is some kind of important, obviously, to the users. After that, we see that the two different products, so the Samsung Galaxy A7 is important for both sales lines, unimportant, independent from the amount of data they have. And the next one is the Samsung Galaxy S8, which is also important for both. And again, for both alternative products, the black color is the first one who is displayed here. Another point is we have the prices. The S8 has a price of 325 euros, and all products are in the range near this price, so plus minus 30%. So altogether, we have the perfect device type in all search results. We have the brand taken into account, the price, the color, and the user is able to find the successors of the product and find new products. So it's a quite good result. So the pros and cons, what did we find out to summarize here? We have now the NDCGs for the search queries with a high amount of traffic, up to date, every day available. We have a lot less manual work. We have a higher accuracy because we now take into account the popularity of each product and not only the product type. Like Diego mentioned, the washing machine, 500 washing machines, but all are equally, and the model doesn't understand which is important and which not. And we have product alternatives for maybe discontinued products. What do we display? We have the perfect product alternatives automatically generated, which is an upside, but also a downside, because the model gets a problem if in one session several search queries occur together. So the example is Nintendo Switch and Nintendo Switch controller, Nintendo Switch game, Nintendo Switch. So in this case, the right products are selected but not ranked perfectly. And of course, a lot of user data is needed. Diego.
Yeah, so just to finalize, well, that's basically how far we are at the moment, and the model has helped us so far to reduce a lot of manual overhead in the area of search management. So now we have all those insights in a more practical way, and we finally have some understanding for kind of alternatives, or how should the true positives be sorted within themselves. And it also helped us to test and see if our current showing order at the shop is not correlating with the NDSG model, then there's definitely something maybe in our ranking model that should be changed or tested in a different way. And basically that's the path that we're going, transitioning to a new search engine. And Georg, want to say a few stuff how we plan to use that?
Yeah. One of the requirements from Diego at the beginning was to have even a better result for the long tail. Currently, the model isn't able to do that. It actually works for the short head, but with the Solar search engine, we will be able to introduce very good field elements. So with the fields, we select the right products that we want to have in the search result, and with the usage of a popularity score for each product, which is similar to the search product score, the relation between both, but without the query part, we get a ranking that is better than just the field information. And yeah, and at the end, we can use this judging model to use something like a learning to rank algorithm. Thank you.
Hi, thank you for the great talk. I'm more interested to know that how do you deal with all of this when there are promotions running?
When promotions are running, yeah, we have this, the line, you saw the red line that smooths the campaigns, and it works for a quite long time, so it resists to change while the campaigns are running. So it's a first basics, some easy start. Maybe there will be some improvement, but currently
I think it's based on a median of the last 4 weeks, right?
Yeah.
So you kind of have this harmonization, what an expected value would be based on this median calculation. And even if you have a very high anomaly, the score doesn't change so much. It doesn't let go to that effect unless that effect persists for a certain time. And then the score will gradually start to correlate with that score change.
Okay.
So how do you cope with new products? Because you're learning from the past, you're not learning from the future, and new products will be introduced and they will not have popularity, but might be relevant.
Yeah, we have the information from similar products, from the scores from similar products for the same search query, and we can calculate something like 80% percentile or 90% and give it as a starting score. And after several days, the product has its own score that is learned from the reality, from the user data.
We're kind of planning to use the model as a kind of plausibility check to what we are developing now. So we have the fact finder results, we have the results of the model, and we could have a third column, which is the results from Solar. and we can kind of use the model as a plausibility check. With Fact Finder, we are already pretty good. With Solar, there's a lot to be done, but we'll get there.